All right, let's see how to find the implicit differentiation or find y prime using example. So the first example is use implicit differentiation to find y prime or dy by dx and then evaluate y prime at the point 3, 10. That means when x is 3 and y is 10. Now the first example is y minus 4x cubed plus 8. So my first step, take d by dx both sides, right? So that means d by dx of y minus 4x cubed plus 8 is d by dx of 0. Now I have to apply d by dx to each term. That is d by dx of y minus d by dx of 4x cubed plus d by dx of 8 is d by dx of 0. Remember, dy by dx, you can just y prime. The second one is when I take the derivative of d by dx of 4x cubed is minus 12x squared. This one is d by dx of 8 is 0. So the other one is 0, so everything becomes 0. So when you solve this one, y prime becomes 12x squared. That is the derivative. Now, what is the question? The second question is evaluating y prime at x is 3 and y is 10. That is 12, because this is derivative is only dependent on x value, so I have to plug in 3 square. This is 12 times 9. This is 108. That is the value. So the derivative is only dependent on x. Let's see another example. So the procedure is the same. So the first step is take d by dx both sides and isolate y prime or dy by dx. So the notation, remember that the notation I can use this one y prime or dy by dx. They are the same thing. Now let's do. Take d by dx both sides of the equation. That means, let's see, d by dx of 8x squared minus y cubed minus 5 is d by dx of 0. Now I have to apply d by dx to each term. D by dx of 8x squared minus d by dx of y cubed minus d by dx of 5, and this one is 0. The derivative of a constant is 0. This one is also 0, right? Now what is the derivative of 8x squared? It is 16x, and the second one is 3y squared. Y prime is 0. Remember, this x is with respect to y, so that's why you don't eliminate and you just keep y prime. But in the first case, d by dx of 8x squared, it is the same with x, so there is no x prime term. So solving for this one, 3y squared y prime is 16x when you set the equation. So y prime becomes 16x divided by 3y squared. So this is the derivative, or y prime. Now what is the question now? Evaluate, right? Now y prime at x is 2, y is 3. Now do you see that the derivative is both dependent on x and y? So 16 times 2 over 3 square. The top one is 32. This is 3 times 3 square is 27. So this is the derivative at at x is equal to 2 and y is equal to 3. So do you understand the implicit differentiation, especially when you take with respect to x of y? So let me add more, the same thing. This one, let me take d by dx both sides. That is your first step. That means d by dx of y squared plus 4y plus 5x is 0. That is, let's say, d by dx of 0 is just 0. So d by dx of the first term is y squared. The second one is d by dx of 4y plus d by dx of 5x. This is 0, right? So what is the derivative with respect to x of y squared? It is 2y y prime, or you can just say dy by dx. The second one is 4 y prime. The third one is just 5, 0. So look at this one. Y prime can be factored out. 2y plus 4 plus 5 is 0. Now, what is our objective? To solve for y prime. So 2y plus 4, when you take 5 to the right side, it becomes negative 5. So y prime is negative 5 over 2y plus 4. That is the derivative. Just to isolate y prime, remember, I have to divide both sides by 2y plus 4. Now, evaluate the derivative at x is negative 1 and y 1. So negative 1, you can look at this one. The derivative is only dependent on y. So I have to substitute only the y value plus 4. So this is negative 5 over 6. That is, the derivative at a point where x is negative 1 and y is equal to 1.